Look around you. Everything you see, everything you touch is made of something. Your chair, the air you breathe, the distant stars twinkling in the night sky. We call this stuff matter. For centuries, we thought we understood the rules that governed it. We learned that if you push something, it moves. If you drop a ball, it falls. These are the rules of our everyday world. The classical physics of Isaac Newton, they make sense, they are predictable, but this comfortable, predictable reality is only half the story. There is another universe, a hidden realm that operates under a completely different, almost magical set of laws. This is the world of the very, very small. This is the world of quantum physics. Imagine shrinking down, smaller than a cell, smaller than a molecule, smaller than an atom itself. Down here, the familiar rules of our big world break apart completely. Let's try a simple thought experiment. Imagine you are playing baseball, you know the rules. The pitcher throws the ball, the batter hits it, it flies in a predictable arc and lands in the outfield. You can track its position and its speed at every single moment. You know with certainty where the ball is and where it's going. This is the world we live in, the classical world. Now imagine a quantum baseball game. The pitcher throws, but instead of a single ball, a wave of possibilities streaks toward the plate. The ball is simultaneously everywhere and nowhere along its path. It only becomes a ball in a specific spot when it's measured. That is, when the catcher's mitt stops it. This is one of the first mind-bending ideas of quantum mechanics. Wave-particle duality. In our world, something is either a particle, like a solid ball, or a wave, like a ripple in a pond. They are distinct concepts, but in the quantum realm, things like electrons and photons can be both at the same time. Now we venture deeper into the quantum twilight zone where the rules get even stranger. One of the most bizarre concepts, one that deeply troubled even Albert Einstein, is called quantum entanglement. Einstein famously called it spooky action at a distance. Imagine you have a pair of quantum particles, let's say 2 electrons, that are created together. They are now linked or entangled. No matter how far apart you separate them, one can be here on Earth, the other can be in the Andromeda galaxy. They remain connected as a single system. What happens to one instantly affects the other. If you measure a property of one particle, like its spin, you will instantly know the spin of its distant twin. If you find the earthbound particle is spin up, you know, in that very same instant, that the particle in Andromeda is spin down. This information seems to travel faster than the speed of light. You might think all this quantum weirdness is confined to laboratories and blackboards, a curious but distant set of ideas. But you would be wrong. You are surrounded by and are using technology born directly from our understanding of quantum mechanics. Every time you use a computer, a smartphone, or even a simple remote control, you are harnessing the power of the quantum world. The digital revolution of the 20th century was, in reality, the first quantum revolution. Without it, our modern world would simply not exist. Consider the microchip, the heart of every modern electronic device. These chips are made of semiconductors, like silicon. Our ability to control the flow of electricity through these materials depends entirely on our knowledge of how electrons behave on a quantum level. We had to understand quantum mechanics to design the transistor, the tiny switch that is the fundamental building block of all microprocessors. Billions of these quantum-powered switches are packed onto a chip the size of your fingernail, performing the calculations that allow you to browse the internet, talk to a friend across the globe, or watch a movie. And so, at base, we have journeyed into a realm where particles are also waves, where they exist in many places at once, and where they can be spookily connected across galaxies. We've seen how this strange world isn't just a fantasy. The question remains, why does this matter to you? It matters because understanding quantum physics is about more than just building better computers. It's about a fundamental shift in our perspective. It's about embracing uncertainty, possibility, and a reality far richer and more mysterious than we ever imagined. It's about our place in the cosmos. Learning about the quantum world is an exercise in humility. It teaches us that our everyday intuition, shaped by throwing balls, watching things fall, is a limited guide to the true nature of the universe. The cosmos is not obligated to make sense to us. By confronting ideas like superposition entanglement, we stretch the muscles of our imagination. Ultimately, the study of quantum physics is a cosmic invitation. The cosmos is calling. All you have to do is listen.